Day 11, 11 sparks discharging. And that's all about static electricity. So static electricity, all objects have charges. And you need to know a little bit about this because you've probably been outside on a day where you heard thunder or saw lightning. That is static electricity. And so I can take this balloon and rub it on my head. And now I got lots. I'm charging it up with some negative waves. And it should be attracted to me. Let me see if you can see it better with this piece of fur and a pink balloon. So I'm going to charge it up, and now there's a lot of negative charges, and they want to repel each other. Here we go. Check this out. Look at this. Can you see them moving? That's so cool. Nature likes to get things back in balance. Whenever there's a buildup of charge, nature likes to equal things out. And that's where you get a discharge or a strike of lightning. But I'll tell you, you can also try this with a tube like this. And if you charge it up, I am rubbing and I can almost hear little bitty lightning strikes. And it does the same thing with being attracted to this. But if I had something that didn't weigh very much, like let's try this tube right here and this piece of mylar. Oh, it's stuck to it. Get it off and it sticks to it. And it sticks to it. So in your dryer, you might use a dryer sheet, which is a piece of cloth that has oil in it. And when it gets warm, it puts that oil up into the dryer to pull out those little charges so your clothes don't stick together. But you know, I have this wand, a flying wand, and it's rubbing a little motor inside, and I'm getting it attracted, and now I should be able to charge it up. And now they are trying to repel each other. Don't say the M word. This is not the M word. It's science. Static electricity. Pretty cool stuff.
We want to share with you Robert Van de Graaf's high frequency generator. And this is called a Van de Graaf generator. And the way it works is you've got a plastic belt. We know plastic is an insulator that goes inside this toroid between two brushes. And as that plastic belt goes around and around, it pulls the electrons off their nuclei until they start to gather on the toroid. And they also ionize the air around the toroid until there's discharge. And we can see that discharge in the form of plasma between the toroid and this discharge wand. You get close, you can see that spark. Those are the electrons that have gathered on the toroid. They're being pulled off because the wand is a conductor and it's pulling them off. Now we can also see the effect of these electrons on this instrument here. When the instrument's away, the strings are down. When the instrument gets closer, watch what happens. They're pulled toward the toroid until it discharges. When it discharges, then they go down. Isn't that amazing? You can also put this instrument right on the top of the toroid, like this, and you can tape it down to kind of hold it in place. And now you can see again the strings are down, but when enough electrons collect on the toroid, they'll start to discharge and the strings will come up. Check it out. They're rising. Isn't that amazing? Robert Van de Graaf, an American physicist born in Alabama in 1901. Here's his generator. Absolutely amazing. Now let's find out if we have a human put her hand on the toroid, what happens with all those electrons. This is Mrs. Kemper's. She is standing on an insulator to keep her from being grounded. Her hand is on the toroid. I'm going to turn on the generator. Look what happens to her hair. Now, Mrs. Kempers, do you feel any shock at all right now?
Not yet.
That's because she's standing on an insulator. She's not grounded. That's really important for safety. She's standing on a plastic box. We can start to see her hairs are starting to, oh, even on her arms they're starting to stand on end. Amazing.